great to be back in Jinan. My name is Momjian. I am from the United States. I am one of the Postgres core team members and also an Enterprise DB employee. I would like to talk to you today about AI and specifically how should databases be used for AI. Because AI is about 4 years old. Relational databases are about 70 years old. Can you still use a 70-year-old technology with an AI database? The answer is yes. But to find the answer to that question, we have to understand some of the fundamentals of AI. So, we're going to talk about how AI has become so popular. We're going to talk about mathematics a little bit when we talk about vectors. And then we're going to talk about training. We've heard the term training a lot with AI, but it's not exactly clear what all this training does. I'll explain that. Then we're going to talk about semantic or vector search. That's a new capability that gives relational databases additional power. Then we're going to talk about generative AI and transformers. And finally, we'll talk about the application of AI. Something called RAG, something called MCP. And finally, we'll finish by showing you a chart that explains where is relational useful in AI and where is relational not useful in AI. As I said, AI is very new. ChatGPT came out November 30, 2022. That is roughly 3.5 years ago. And it feels like a long time, but this is our AI world now. It clearly changed the entire landscape of AI. AI has been around for a long time, but ChatGPT really changed it. Before ChatGPT, AI was known for mostly doing things that are discriminative or predictive. So things like classification, recommendations, and predictions were very popular with AI. But with ChatGPT, we have something called generative AI. And the reason this was so revolutionary is because it allowed AI to generate new content. It was no longer recommending existing content. It was no longer classifying existing content. It was creating new content. And that new content was talking back to you. That excited many people. Some of the uses of generative AI, chatbots was an early one. Semantic and vector search I'll talk about today, but also things like image creation. And I think for technology people, software creation, we're hearing a lot about that in the past 6 months. Claude Code, a lot of, not clear what's happening, but interesting. Code analysis, I've used that several times. Data analysis with AI, even programming language conversion, I think, is a very productive use for generative AI. So again, before generative AI, things were discriminative. You did training on very specific domains. Now with generative AI, you have a much more powerful capability. This is really what discriminative AI looks like. It's trying to draw lines between various existing objects. Generative AI is basically made of a bunch of vectors, and I'm going to explain why the vectors are so important for generative AI in this talk. Okay? So, I was a mathematics teacher, so I like mathematics a lot, and you do need to understand some level of mathematics to understand how generative AI works. So, with mathematics, you can represent a whole bunch of things that don't exist in the real world. Things like infinity. Infinity is not a concept we normally can see, but we can represent it in mathematics. We can represent very large numbers, like the number of atoms in the universe. And we can even do calculus, which allows us to make very small calculations. Again, very easy to do in mathematics, very hard to do in the real world. Why is this important? Because the fundamental way that generative AI works is to create vectors in very high dimensional spaces. Okay, I know some people are like, wow. Normal world that we live in is 3 dimensions, right? Length, width, and height. But imagine if you could represent an object with more than 3 dimensions. And that's exactly what generative AI does. It represents words or parts of words in 1,000 dimensions and sometimes 10,000 dimensions. Okay? So I know we can't see 10,000 dimensions. I tried to represent 10 dimensions on this slide. So the X and Y is 2 dimensions, and then up in the right corner we have another graph. That's my 4th dimension. And then in that corner of that graph is another dimension, that's 6, and then go up as 8 and then 10. So imagine you do this to 1,000. Okay? Obviously we can't really comprehend what that looks like visually, but it gives the vector space a very powerful way to represent the language and the word relationships that we take for granted. This was revolutionary. We can thank ChatGPT and also Google for a lot of this research. I'll explain that later. So, effectively, what happens is to train these vectors, the way it works is you start with effectively all the words, let's say in the Chinese language, or all the symbols in the Chinese language, or all the words in the English language. And you create random vectors for all of the Chinese characters or all of the words. Okay? So you just create random vectors in this dimensional space. Maybe it's 30,000, 50,000 vectors. But of course the space is so big, the vectors they're all over, they're not near each other at all. Okay? And then what we do is we use something called word to vec, and we actually adjust each word depending on the words that surround it. I know that sounds like it shouldn't work, but it does. Let me show you an example. So here's a vector, 4 vectors. I have man, woman, king, and queen. And I've just randomly put these vectors on the graph, on the chart. Okay? And then what I do is I train the vectors. So I take the sentence, the king is a tall man. And I move the closer to the blue words. I move king in the second one closer to the words. And I do that for all the words. Okay? So king gets closer to man, tall gets closer to man and king, queen gets closer to woman, beautiful gets closer to woman and queen, throne gets closer to castle. Because the sentence up here, you can see queen is near beautiful and throne, woman, and castle are together. Okay? And you do this billions of times. You ingest all the documents in the entire internet. Okay? And then all the books that have been written in the past 100 years. And you just move these vectors slightly with all of this text. Okay? So, the becomes closer to king, throne becomes closer to room, throne room becomes closer to castle. These dimensions, these vectors are moving in that 1,000 or 10,000 dimension space. Okay? So at the end of all this training, what I have is I have man and woman are very close to each other. Because normally, man and woman in the text appear near each other. And I have king and queen, which are also close to each other. Because normally king and queen would appear together. But what's really interesting is the distance between man and woman is the same as the distance between king and queen. So if you take king, the vector for king, you subtract the vector for man, you add the vector for woman, you end up with queen. Again, this is as you train these vectors with millions or billions of documents. Okay? And that's kind of what the vector embedding looks like. I know it's really hard to represent, but you get the idea. Okay? So how do we make use of these vectors? Well, there's really two major uses. One is semantic or vector search, which I want to explain now, and then generative AI, which I'll talk about in a minute. So let's talk about semantic search. You've probably heard of it. Semantic search, normally when we do a search, we search for words, right? We search for car, we search for umbrella, we search for apple, okay? But when we search for words, the system is looking for a word to match. It doesn't know that apple and banana are related. It doesn't know that king and queen are related. It just knows letters, or it knows Chinese characters, okay? What's really interesting, semantic or vector search, when you use the training, you can bring meaning into the search, and I'm going to show you how. So the way we do this is we take a document. Well, first we take a pre-trained embedding, and then we create a document, and we break the document up into parts, and we store it in a database, typically Postgres. And then once we store this special vectors, we can actually do searches that have meaning, and I'm going to show you exactly what I mean. So, the way we do it is we take every document, we look at all the vectors for the words in the document, and we average all the vectors together, and we get like an average vector for that document or that sentence. And we store that in the database. Then we do the same thing for every sentence. So by the end we have a storage, and then when we want to do a search, we average the vectors for the question. And we look for the closest vector to the question vector. See, we have two types of vectors. We have vectors for documents, and we have vectors for the search. Let me be specific here, okay? So, I have 3 sentences. King's a tall man. 6 words, 6 vectors, okay? Queen is a beautiful woman, same thing, okay? They sit together in the throne room of the castle, that's 10 vectors, and we average those together, okay? Then when I search who is the king, I end up averaging the words for king, and it actually finds the king is a tall man because it knows that that vector, who is the king, is close to the vector the king is a tall man. Okay? Let me show you some actual code. I'm learning PG Vector here, and I'm creating some SQL to store my documents, my sentences, and then also to store my vectors. So I'm going to insert my 3 sentences like this, okay? And then I'm going to use some Python code, and I'm going to insert the vectors for each of those sentences into the database. Now, I'm not storing a vector for each word. I've averaged the words in the whole sentence to make an average vector. That's what I'm storing. So if I take a look, I have 3 sentences here, and you can see I have 3 vectors. Okay? Now, when I want to do a search, I actually, at the top, if I'm doing a search, I find the words in the search, I create an average vector for those, and I use Postgres in the red here to do a vector search and say, give me the closest vectors to that particular question. Let's look at an example. Who is the king? We get the king is a tall man because that's the closest one, right? Who is tall? I get the king's a tall man. That's good. Who is short? The king's a tall man. That happens because it knows tall and short are related to each other. Remember I said that with king and queen it knows they're related, man and woman knows they're close? Same thing. Who is pretty? The queen is a beautiful woman. How do we do that? It knows that pretty and beautiful appear together often in documents. Okay? Who is in the palace? They sit together in the throne room. That's because palace and castle are known to be similar. And finally, where is the chair? It gets that sentence because there's a sit word and a throne. Both are related to chair. It knows that because of the vectors of all the training that happened. So as you can see, it gives the database a very powerful ability to do searches. I said there was one other use for this training, and that is generative AI. Basically, the way we do generative AI is that we basically create things called attention blocks, okay? And we basically take the training vectors on the left, and we take the question, the query, and we look up the vector for every word, and we put it in something called an attention block. The question is, what is the capital of France? Okay? So, those are my 7 words. And that's my attention block right there, 7 little slots. So I adjust is to be close to what? Is now close to what? I make the close to what and is. Now number 3 is what is the. I have capital close to what is the. I get that. I have of, I keep moving. And this is after the first attention block. I basically moved the words kind of close to each other, the vectors. The vectors are moving close to each other. And I do this dozens of times. ChatGPT 3 did it 96 times. So, basically every time I cycle through, these vectors get a little closer to each other based on the other words in the query. So after the first attention block, this is what I get. It looks like this. Second attention block is this. Fourth attention block is that. Do that 96 times, or 100 times, or 200 times. And what happens when you continually do this is you get a vector at the end of the attention block, and that vector at the end of the attention block is the answer to the question. We know the capital of France is Paris. And it turns out when you run this enough, that becomes Paris. Just like the way that the man and woman king and queen were. Okay? So again, we get our first word, then we run it again, we get our second word, and we just keep running until all the words come out. All right? That's word 1 and word 2. Let's look at a better example. What is the capital of France? The capital of France is Paris. It does that by running through the attention blocks. Okay? Where is Paris? I get a bigger description. Okay? You may know there is a Paris in Texas. So I know everyone thinks Paris in France, but there is a Paris in Texas in the United States. So if I say Columbus is in Ohio, where is Paris? System's not sure about France anymore. Okay? And now it says Paris is in France, but because I mentioned Ohio, the vectors have been shoved closer to Texas. And I actually get some information about Paris, Texas. If I say I live in Texas, where is Paris? It automatically starts talking about Paris, Texas. Because the attention blocks, the word Texas in the attention block has adjusted the vectors to be closer to Texas than they were to France. Right? Once we have generative AI, we can modify it in some powerful ways. One great use of databases is something called retrieval augmented generation, or RAG, and that allows you to modify the attention block. It allows you to modify the vectors that are used in the attention block. So for example, if I add in red here, reply briefly in the attention block, I get a much shorter answer, right? What if I say Columbus is in Ohio, where is Paris? Again, I start to talk about Texas a little bit, okay? And take me down here because I say I live in Texas, okay? What if I use JSON? What if I put JSON as part of the attention block? So I've decided to create these 3 JSON records, and I'm going to add this to the attention block, and I'm going to ask questions about .json. So I'm going to say, when were the orders made? And because of the way that generative AI was trained, it understands the JSON to the point where it can actually list out the orders, and it even knows the earliest order of those 3, just from the JSON, just from running it through the attention blocks. Okay? I can ask for the total of all my invoices. I can ask for the average invoice amount if I want to. Okay? I can even ask unusual questions. Which invoices are overdue? It knows what overdue means. It understands how it relates to the JSON, and it can actually process and tell me which orders are overdue. Pretty amazing. I can say which invoices are not pencils. I can even ask for predictive orders based on the dates of the orders. Pretty powerful. I can have it write SQL queries. I can say, give me an SQL query to find the latest invoice date, and it'll do it for me. And I can even use PSQL to automatically generate my JSON for me, dynamically. So I don't have to send the same JSON. Every time a customer asks a question, I can prefix that customer's question with some JSON about their location, about their invoices, about anything I think is relevant to that customer, and that's going to help the generative AI give me a better answer. Great use for a database. Another great use for a database is Model Context Protocol. I actually have a new talk about this. I'm giving it in Armenia on Tuesday next week, so I'm sorry I'm not able to do it here. But Model Context Protocol has become very popular in the past year, highlighted by Claude, and it allows generative AI models to call external tools to get external data. So things like total revenue, weather, price. You can have the MCP tool do actions like send email or book flights. How does it actually work? Well, you basically create a resource, and then you register that resource with the generative AI, and there's a standard API that knows how to call these resources. So we have basically the ability to do semantic search with AI. We have the ability to generate text with AI. We can use RAG to improve it. We can use MCP to improve it. Okay? But this is the slide I think is most important. It tries to explain what is good for a relational database in terms of AI and what isn't. For example, I talked about training and the need to process billions of documents. It's probably not a good use for a relational database. Probably too slow. Probably too much overhead. We don't need transactions. We don't need, concurrency control and isolation. Probably not a great tool because there's so much data involved. Semantic and vector search, that's a good use for a database. Transformers and generative AI, again, huge amount of computation, probably not good for a database. Retrieval augmented generation, absolutely. MCP, absolutely. Large language queries to retrieve data, that's a good use for a database. And again, also MCP, as I said. You don't have to use you don't have to use ChatGPT or Claude. You can create your own generative model if you want. You can download them if you want. There's a whole bunch of, DeepSeek is a big one I know. Llama I hear a lot about. There's a lot of them out there. You can find, very easily find those. Okay? There is a lot of activity in the Postgres space with AI. PG Vector I already talked about. PG Vectorize is another sort of vector extension for Postgres. My company EDB has something called AIDB. There's PGAI. There's a vector cord, a whole bunch of things that are available in the Postgres space for AI and MCP actually. I mentioned that this is all fairly new. What's surprising is that Google actually started working on this in 2013. And they basically create a lot of the foundational aspects of generative AI. The problem, they were so focused on the existing business model that they did not really take advantage of it. ChatGPT was able to do that. So I'm going to finish with these two quotes. This person is shocked at how fast AI has improved. They said the things it does today, I wouldn't have thought a year ago were possible. So it's really hard to predict where AI is going. It's moving so quickly. But secondly, I think this is a very good article. What this person says is that just because it looks like AI can talk doesn't mean it has any idea what it's saying. Effectively, what AI is doing is statistical prediction of words. That's all. If you do it 1 billion or 10 billion times, it starts to sound like it knows what it's saying, but it has no clue. So this is why it hallucinates. This is why it's hard sometimes to trust AI for critical workloads, and this is why you often have to monitor what AI is doing to make sure it doesn't do something bad. Thank you very much. I appreciate your having me here. I'm looking forward to the rest of the conference. Thank you.
感谢各位的精彩分享。又深刻地揭示了数据